Hello students, this is Dr. DA and welcome to your first actual experiment in the Chem 1A lab. Today we are going to be talking about the melting point, a very important physical property that allows us to identify some substances and also allows us to assess for the purity of a sample to see if it is free of contaminants. In today's lab, you're going to be given an unknown substance, and by doing the experiment, you'll be able to determine which of three possible candidates it is. So we're going to give you a demo of the procedures, and we're going to walk you through a sample set of calculations also. So get ready, let's go, and here we go. Okay, students, today's experiment is about melting point. In class, we talked about what is a physical change. We said that it is a change that doesn't affect the composition of the substance. In other words, the substance is still the same identity as it was before the change happened. One example of physical changes are changes in the physical state of substances. So we know, for example, a substance can be in the solid or in the liquid state. The process of changing a solid into a liquid, we call it melting. And the reverse change, we call it freezing. Now, because the melting and freezing of substances is very unique to each substance, we can define a physical property called the melting point, T sub m. This is the temperature at which the solid becomes liquid. In the same way, we can define what is called the freezing point, T sub F, the temperature at which the liquid becomes solid. Later in the semester, we will study these processes in more detail and probably arrive at a better definition of what these are. Now, since melting and freezing are essentially the reverse of each other, the temperature at which the solid melts should be the same as the temperature at which the liquid freezes, and so ideally, the freezing point and the melting point should be the same. However, in practice, that is not the case. So let's look at an experiment with a pure substance and draw what is called a heating curve. So what we're going to do is we're going to measure what is the temperature of the substance as we add heat to it. We're going to heat up the substance. Let's start out with a solid and start measuring the temperature. What we'll notice is that as we begin to add heat, the temperature starts increasing and increasing, and then at some point, curiously, it starts leveling off quite a bit and reaches sort of a plateau. It's not completely flat, but it definitely doesn't change that much. And then after a while, we notice that it picks up again and the temperature starts increasing once more. At that stage, though, the substance is already a liquid. That means that during that quote-unquote plateau of temperature, melting was happening. Now, if we had done the experiment in the reverse direction, in other words, if we had started with the liquid and started removing heat, this would be in the opposite direction, and so the temperature would lower until it reached this plateau, during which you'll have freezing of the liquid into a solid. We can use the heating curve to establish what the melting point and the freezing point are. What we'll say is that the point at which the plateau begins in going from solid towards the melting phase here, we're going to call that the melting point, Tm. And then when it begins to rise again at the other end of that plateau, quote unquote, we'll call that the freezing point. Notice that they are not exactly the same, but they're very close to one another. And so we can say that if a substance is pure and you do this experiment, the melting range, that is the difference between the freezing point and the melting point, is going to be very narrow. In other words, the difference is very small. Now let's see what happens if instead of a pure substance, I have an impure substance, right? For example, I have a preparation that I've made and it still has some impurities in it, or I've mixed it with something else. Let's again draw our heating curve, in this case with an impure substance. Again, we're going to start with the solid and watch what happens. As I begin to add heat, the temperature once more starts rising. But what's interesting is that the plateau is reached at a lower temperature. The plateau is not as flat, it's actually pretty steep also. And then you arrive again at the inflection where you are going to be converting the whole thing to liquid. So notice that if I again apply my criterion of taking the point at which the temperature starts reaching that plateau as the melting point, the new melting point is over here. And again, the new freezing point would be over here. And what you can see when you compare them to the ones on the left side is that for an impure substance, the melting and the freezing points are lower. It has lowered that. Later in the semester, actually towards the almost the next to the last unit, actually the last unit actually, we are going to study this phenomenon again and find an explanation for why this happens. The other thing you notice is that now the difference between the freezing point and the melting point, in other words, the melting range, is broad. So if I have a preparation of a substance, one way to assess its purity is to check and see if the melting point is close to what it's supposed to be, and also if the melting range is narrow or broad. The narrower the melting range, the purer the substance is. Now we can also use this to play a trick in terms of identifying substances. So this is our strategy for today's experiment. You're going to be given an unknown compound and you're going to identify it as one of three possible candidates: benzoic acid, transstilbene, and succinimide. Now here's the thing. All three of these compounds have similar appearance and they have very similar melting points. So in other words, we don't have the level of accuracy in measuring melting points to be able to tell that our unknown is one of these three just based on that. And in terms of appearance, they all are white crystalline solids. They all look about the same. So there's not a lot of identifiers, but here's what we're going to do. We're going to take our unknown and we're going to determine the melting and the freezing points of our unknown preparation. Then what we're going to do is we're going to mix it with one of the three candidates and we're going to determine what is the melting point and the freezing point of that mixture. Notice that if the melting and freezing points of the mixture are lower than the unknown alone and the melting range is broad, that means that this mixture is behaving as an impure substance. In other words, the unknown and the candidate compound are not the same. The candidate compound is behaving as an impurity when you mix it with your unknown. If, on the other hand, the melting point and freezing points of the mixture are similar to the unknown by itself, and the melting range is narrow, then the mixture is behaving as if it were a pure substance, which means that the unknown and the candidate compound are identical. And this is how we can identify which of the three compounds was our unknown. Okay, so let me show you now how to carry out the procedures and use the equipment. And then after that, we will look at a sample set of data so you can learn how to analyze your results. Thank you.